Welcome to Study Loop.
All right, so here we have some data on heartbeats per minute, and you can see the heartbeats were calculated for each of these specific minutes, starting from 36 minutes to 44 minutes. And what we're going to do is estimate the heartbeats per minute by doing a secant line slope. So part A, and basically secant line slope is just doing rise over run on the points. So for part A, we'll just take the time, actually I don't want 26. I'm going to simply go between 36 and 42. So this interval, and I'm going to do rise over run. So 29:48 minus 25:30, that's our change in heartbeats, over our change in time. 42 minutes minus 36 minutes. So these are heartbeats. Okay, so rise over run, heartbeats per minute. So let's get that numerical value. Let's plug it in our calculator. So 2948 minus 2530. We'll divide by 6, which is the difference in minutes. And we get a heart rate of 69.67 heartbeats per minute. Okay, now we're going to do secant line slope, but this time we are going to go from 38 to 42 to see what basically that average heartbeats per minute will give us. So we're going to do rise over run again. So 29:48 minus 26:61 heartbeats. So I'll just write it as beats. Beats per, this time we're going to do our run is 42 minus 38. So that's in minutes. Okay, so then that, if we plug in our calculator, we get 2948 minus 2661, divide by 4 minutes. And that gives us a heartbeat rate average between those two periods is 71.75, and I'll just write as beats per minute. All right, excellent. So we can see that as we're narrowing the time window already, our beats per minute's rising. Let's keep going. And clearly, if we look at the data, we can see the beats per minute are increasing all the way throughout, so that if we start from the beginning and go to 42, we're really averaging in a low end. So it is important, as if we want to see what we're at 42, we have to get as close as we can to 42 in the delta time, but let's just keep going. Okay, so let's do part C. We're going to do between 42 and 40, so that's pretty close. So our rise over run is 49:48 minus 28:06 beats per delta, so 42 minus 40 minutes. Okay, so let's do that in the calculator real quick. 2948 minus 2806 divided by 2 minutes. So we get 71 beats per minute. Okay, excellent. So we can see that in all of these, it kind of was rising, then it went falling a little bit. Overall, it's rising just how our averages came out to be. Okay, so finally look at D. Now D is looking at this interval here. So let's go ahead and do rise over run for that last interval. 3080 minus 2948 beats per 44 minus 42 minutes. So let's do that. 3080 minus 2948 divided by 2 minutes, and we get 66. So this is 66 beats per minute. Okay, so the data is actually just showing it looks like the heartbeats from the beginning, and then just, keeping a kind of a cumulative tally. And we're looking at heartbeats per minute. Okay, because actually this would be, if these were heartbeats per minute, it'd be crazy. So this is just total heartbeats from the beginning. And then this is the time recorded on the stopwatch. Okay, so What are we seeing here? We're seeing that from A to C, what we're seeing is that as you get closer to our value of interest, 42, as we get closer, when we do a secant line slope, the closer we are into the value of interest, the more accurate we'll be. And we can see we kind of honed in at 71 beats per minute. Then we can kind of see that after 42 seconds, it actually decreased. So that's kind of neat. Anyway, so that's kind of fun work with data and secant line slope approximation to, in this case, heartbeats per minute. All right, have a wonderful day. Hopefully that helps. See you next time.